All right. So it seems, yes. So it seems that most of you are here already. So let us start now our discussion for today. So before we'll start, do you guys have a question so far regarding with our past activities, our past discussions? Any
Not so far, sir.
questions? All right. Okay then. So I hope that you guys have already checked this one out, the week 2 introduction to electronics. Though I'm pretty sure that maybe 80% you guys already know what is this all about. Okay, so here's the overview of the module 2. I mean module 3 rather. So as you guys can see, we have here the topic learning outcomes and then the list of topics that we're going to discuss. And
Okay.
here are the learning resources. So of course we have the PDF, which I have already uploaded in here. So please download this one so that you can have your own copy while we are having our own discussion. And then for the video materials, so you can always visit this one, right? So just go to this page, module overview, and then just left click those links. So those are the links that will help you to understand more what is electronics all about. Okay. And then I have also, where is that one? Here. I have also included here a reading materials wherein it is a guideline on how to use the FreeSync. Okay. Is there anyone here who have experience in using FreeSync? Have you guys heard what is FreeSync?
No, sir.
Familiar lang. Familiar lang, sir.
Familiar?
No.
So FreeSync is actually similar with EagleCAD, but this one is quite more user friendly. Let's say that this one is for beginners, and EagleCAD is the one that is being used in industry, okay, for professionals. So FreeSync is, meron pala ako dito. Okay. Right, so FreeSync is an application wherein it will give you a virtual components. Like for example, of course, you have here the real components, right? But in FreeSync, you can have the virtual breadboard, virtual what is this one? I don't know, potentiometer maybe. And we have some wires, and then we have the servo motor, and then the Arduino. Okay, so like maybe 90% this one is complete if this one is updated. Okay, 90 to 95% the components that you'll be needing is already in here. Okay, so this is the first step that you might be needing when it comes to drawing a schematic, especially if you're doing it in virtual first before doing it on the actual breadboard. But you can do either of those two. But if you are more concerned when it comes to your components getting destroyed or getting uh, maybe getting failed because of your connections, then it might be safer to use FreeSync first, okay, before you will do this one in actual. Okay, so as you guys can see, we have here a lot of projects, and then you can do that one also in the FreeSync. Okay, so basically this one is just a brochure wherein they are saying what is FreeSync, who uses FreeSync, what is the use of FreeSync, and what are the things that we have accomplished using FreeSync, etc., etc. Okay, so mostly these are projects or workshops that we have created using this application. Okay, and here's the virtual, and then here's the actual PCB board. Okay, and what else? So yeah, I guess that's it. And then the other two reading materials is all about electronics. Okay, the basic components, how to use them, what are the usage, when to use them, etc., etc. Okay, and most of my let's say ideas came from this website. Okay, explain that stuff. Okay, so in here it's basically explaining all of the basic components resistors, diodes, capacitors, transistors, optoelectronic, circuits and circuit boards, etc., etc. Okay, and then the history or a short history of electronics. Okay, so please visit this one. And here's now the PDF, which will be discussed later on. And then I have also included here a link, okay, where you can download and install a FreeSync. Because if you're going to visit their official website, you have to pay. Okay, you have to pay for you to be able to download this one, like $8 or euro. Is this dollars or euro? That's correct, euro. Or yeah, I guess this one is euro. So 8, ano bang tawag doon? 8 pounds? Tama ba? Ganun ba yung tawag nila sa euro? 8 pounds, 25 pounds. Anyway, so yeah, you have to pay for this application, okay? But of course, we have ways to download the crack file or the crack version. Okay, so I have this tutorial on how to install and download FreeSync for free. Okay, so just watch this video. I guess this one is 4-minute video. So yeah, just visit this link. Okay, and then here's some tutorials or FreeSync tutorial on how to use FreeSync. Okay, so just click this one. Okay, so I guess this one is 7-minute video.
Hi guys, it's Roman Kotak here.
So this is just a short introduction and how to bring out the breadboard, how to go to the parts, etc., etc. Okay, and then how to put the component to your breadboard, and so on and so forth.
The properties of the resistor. For
And
example,
here's where you can edit the values, etc., etc. Okay, so everything is in here. Okay, maybe not everything, but at least the most thing that you'll be needing when it comes to creating a simple project is already there. Okay, so please do check those two. Okay, and then under watch videos, so I have also included all of the tutorials. I mean, all of the introductions, okay, that can be found on the YouTube. All right. So here's a YouTube where it will explain about capacitors. It will explain about inductors. It will explain about ICs, transistors, etc., etc. Okay. And I've also included here a FreeSync exercises. So this one is optional. Okay. So it is not completely up to you if you will do this one. Okay. So this one is a 7-slide FreeSync exercises. So we have here the introduction on what you are trying to create. So of course, you will start with a very simple project, a blinking LED on pin 13. Okay, so this one is much appreciated if you have your own Arduino. Okay, so this one is really, useful. Okay, when it comes to starters in creating a simple project. And by the way, guys, maybe you will be having or will be adding additional topic when it comes to Arduino, okay? Because like drafting and design is related or is partnered with, okay? It's partnered with Arduino, okay? So they always go together. So the components and then how to control them using Arduino, okay? So this one is a 7-slide. Yeah, so this is another project. Where is the next button? This is another project, etc., etc. Okay, so those are just simple projects wherein, we just need simple components like servo motor, potentiometer, LEDs, resistors, and maybe some capacitors. All right. And I've also prepared the lab number 5 here. So later on, we'll talk about this one while we're discussing our module 3. And of course, there's another case study number 3. So we will discuss this one later on once we're done with our discussion. All right. So are you guys ready now to start our discussion with module 3?
Yes, sir.
Yes, sir.
Yes, sir.
Good. So this one is just super simple. Okay, like this one is literally for electronics 1. Okay, so this is might be the introduction that we are also using when it comes to introducing electronics. So first, let's start with an atom. Okay, what is an atom? So you guys may already know that an atom is the smallest particles that we can find, or we have ever known in our entire life. Okay, but an atom is composed of still, four parts. So we have here the electron, the nucleus, and then the protons, and then neutrons. Okay, so the protons and neutrons is the one that is on the middle, and then the nucleus is maybe the outer part, this one, and then the electron is the one that is rotating, or call this one orbiting. So the correction, orbiting uh, on these protons and neutrons. Anyway, so mostly this is what they will show when it comes to an atom. Okay, just to give you guys an idea on where is electron, where is proton, where is neutron, then where is nucleus. Okay, so let's have a short history when it comes to atom. So atom is actually the fundamental building blocks of chemistry. So I will show you guys later on why this atom is building blocks of chemistry, like the periodic table of elements. Okay, so let's start with this cookie. Okay, like in everything or in anything. Okay, so we can actually figure out what are the ingredients, or what are the particles that is inside of that thing. Like for example, a cookie. So it has a flour, it has a sugar, has a brown sugar, has a chocolate chips, butter, baking soda, thus creating a cookie. Okay, but if you're going to go deeper, like let's just focus on the sugar. Let's say this one. This one still contains another element. Okay, wherein this one contains carbon atoms, contains oxygen atoms, and then hydrogen atoms. Wherein, as you guys can see, this one is like parts of our periodic table of elements. Or you can see that this one is a single element, carbon atoms, and then another element, which is oxygen atoms, and then another element, hydrogen atoms, which is now inside of our periodic table of elements. Okay. So even the screen that we have right now, or that you are watching, where you are watching maybe your phone, or maybe your laptop or desktop. So your screen, your my bottled water, my paper right here, anything, okay? All of them composed of an element that is under periodic table of elements. Okay, so you can extract it to its most little or smallest part, wherein it could be hydrogen, it could be lithium, it could be beryllium, boron, carbon, and so on and so forth. That can be found on this table of elements. All right. So even the ice that we have right now. Okay. So it has an oxygen atoms, carbon atoms, hydrogen atoms, phosphorus, nitrogen, and so on and so forth. But we can go deeper. Okay. Like for example, a calcium atom. So of course, there's a lot of calcium atoms, and if you're going to zoom it in, or figure out more what are the particles inside of the calcium atoms, okay, that's where you can find a atom, or a single atom. So we could say that this one is composed of millions of atoms. Okay, this one single calcium atom. Okay, so this is already an atom, but there is a deeper, a smaller part of that atom, which is a single atom. Okay, so in here you can see that it is a human hair is roughly 500,000 times wider than an atom. So our hair is already super thin, like it's hardly seen by our eyes. And then make it much more smaller, 500 times. That's the size, or roughly, okay, that's not exactly, but roughly the size of an atom. Okay, so this is just a sample image, okay, just an assumption image coming from our calcium atoms. Okay. So we have a lot of kinds of atom, but if you're going to zoom that one in, so later on you will see what is the correct color, or the actual color, okay, of an atom. All right, so let's go back to the 400 BC. So as you guys can see right here, this is Democritus, wherein he came from an idea, like you can cut an apple, and then you just keep on cutting it, okay, half to half, like infinity, until there is this part that you cannot cut it further anymore, okay. So in that time, he assumed that yeah, until the part that you cannot see it anymore, that you're still cutting something, okay, he assumed that that is already called atom, okay. And before, it's not called atom, but he called it atomos, okay. So from here, just jump right here. He called it atomos, wherein he said that atomos means uncuttable in Greek word, okay. But due to lack of evidence, so many people rejected his idea. Well, he just, came out with an idea on, what are the things that we can find if we keep on cutting something, like for example, an apple. And then, yeah, until he cannot cut anything anymore. And then that smallest thing that uh, he cannot cut is now called atomos. Anyway, that was long, long time ago, 400 BC. So he wasn't able to uh, not encourage, wasn't able to what do you call this one? Mm, ang proper term, hindi niya nahikayat, hindi niya na kalimutan ko yung term. Hindi niya na anyway guys, ang gusto kong iparating. Na-encourage yung naiisip ko pero hindi niya na-convince. Yeah, tama. Miss Lanila. So he wasn't convinced. He wasn't able to convince the people around him that the smallest thing that we cannot see anymore is called atomos. Okay, so moving on. We have here 780 after that, which is I don't know if this one is a historian or scientist, but he is Jabir ibn Hayyan, so maybe he is a scientist. So he have this process wherein from seawater, okay, you can form, so you just keep on, putting on fire and then forming a salt, okay. But he developed, or he figured out another process on how to extract smaller particles or smaller elements inside or of that element, let's say salt, okay. So as you guys can see right here, he has 4 processes. So filtration, boiling, and then vapor collection, and then cooling. So from that part, you figure out that you can find out more elements or particles on one thing, okay, or on a specific thing. Like for example, a fruit. This one contains a water. This one contains an alcohol. This one contains an acetic acid, a sugar, a pulp. Okay, and he wants to figure out more what's inside a water. Okay, so that is now where Antoine Lavoisier, I don't know if I pronounce it correctly, but this one is a French name, and Marie-Anne Paulze. Okay, so this one is 1700 AD. Okay, so they wanted to expand the idea of Mr. Jabir bin Hayyan. Okay, so from the water, okay, he wanted to figure out what else more that we can find on the water. Okay, so they figure out, okay, that they can still extract more elements, the individual elements, like called the hydrogen and then oxygen, okay, which now leads us to the elements, which is the primary constituents of matter that cannot be created or broken down through normal chemical reactions. And then, of course, they didn't stop there. Okay, so they wanted more to figure out what's inside. Okay, what are the particles of hydrogen and oxygen? But as time goes by, they failed. They cannot extract any other elements anymore or any other particles. So instead, they just listed this one as the smallest particles for now. Okay, so they listed it on maybe. So before, they don't call this one periodic table. This is just, a list of elements. Okay, so they've started with H and O until they figure out another elements and then keep on adding that one on the list of the elements. Okay, and then as time goes by, before until right now, so as of now, okay, we only have found 118 elements. So when we see elements, that is a particle that we cannot divide anymore. Like it doesn't have any particles or any other elements on that element anymore. So it's like an individual element, okay, that you cannot cut anymore. Okay, so that is why we have this periodic table of elements right now, coming from the ideas of Mr. Jabir and Mr. Antoine Lavoisier, and then Miss Marie-Anne Paulse. Okay, so where is the atom? So as time goes by, actually we are just assuming that we cannot really see an atom. Okay, it cannot even be seen by a microscope. Okay, so that is why they cannot show a single picture of an atom. But there is this one guy wherein they figure out how to scan, okay, how to touch, how to measure its size, okay, and then what does it look like. Okay, so the or someone invented scanning tunneling microscope, okay, wherein this microscope will be able to pinpoint one single element. One na nga single pa. Well, one element or a single element. Okay, and then what they're trying to track in here is the size. So as you guys can see, the green right here is actually the light, and then the red right here is the reflection that is coming from this nitrogen atom. Okay, so this microscope or scanning tunneling will move little by little para makuha nila yung size hanggang sa tatamaan dito, magre-reflect doon. It will hit this part and then it will reflect there. It will hit this part and then it will reflect there and then again until they will be able to, you know, see the size of it to its smallest part or smallest point. Okay, until we have captured this image coming from this scanning tunneling microscope. Okay, wherein we have this part. Okay, I don't know if it's red, but they said that this one is just an image processing picture. But every pixel, as you guys can right here, the red contains the process of every light that it hits. So if you're going to count the pixels, that's how many times it hit the light, the atom. Okay, so they didn't say the specific size, okay, the specific size of the atom, but it's roughly where is it one? It's roughly 500 times smaller than of a human hair. Okay, so yeah, sobrang liit. Okay, so that's now going back to the original form wherein this atom contains an electron, nucleus, protons, and then neutrons. All right, so did you guys learn something from the short history of an atom?
Yes, sir.
Yes, sir.
Yes, sir.
There is another thing that I find.
Yes, sir.
So when we say atom, marami palang klase ng atom. Okay, so this is just the image of a nitrogen atom. Okay, so atom na to, isa lang to. Meron pang atom na, saan na yung mga atom kanina to? Meron tayong, we have calcium atoms, we have nitrogen atoms, we have phosphorus atoms, we have hydrogen atoms, etc., etc. So all of our elements contains an atom, wherein it is the smallest part that compose of that single element. Okay, like for example, this hydrogen is maybe composed of 500,000 atoms. This helium is composed maybe 400,000 atoms, and so on and so forth. So all of them has their own individual called atoms. Okay, like indivisible element. Okay. All right, so let us now move to the electronics, which is the main topic of our module 3 or discussion for today. So what is electronics? So it is derived from the word electron mechanics, which means to study the behavior of an electron. Okay, so before, this is how they call someone that is studying about electron. But as time goes by, okay, they generalize it or categorize it to as electronics only, because we have a lot of different parts or specialists or expertise when it comes to electronics. So later on, you will know what are the branches of electronics. But before, it's just one, which is called electromechanics. But as time goes by, it's now generalized as electronics. Right, so the device which controls the flow of electrons is called the electronic device. Okay, so any device that has a flow of electrons is called electronic device. Okay, so you can see that all of our appliances that uses electricity is called electronic device. Okay, so these devices is the building block of electronic circuits. Okay, and the motion of electrons through a conductor gives electric current. Okay, so it could be done by a source of power, like for example, batteries or generators, okay, or any source of power or electricity. Okay, so once there is a source, of course, it will keep on providing or giving you a flow of electrons, okay, which is now called the electric current. Okay, so let us now move on to the branches of electronic. So as I'm saying a while ago, we have a lot of kinds of electronics. We have digital electronics, which deals with digital signals. So this one is just like maybe one of the new findings when it comes to electronics, because before we're only using analog, okay, analog electronics. But then there is this digital electronics, which is much more reliable due to lesser error and lesser noise. Because as you guys all know, when we say digital, it only has two value. Okay, it could be 0 or 1 only. Okay, so example, this one is continuous audio signal transmitted as a sequence of ones and zeros. So it can be reconstructed without error. So they're very, very reliable. But analog is still reliable, especially in some cases wherein we really need a real-time variation, wherein from point to point. You can say that analog is the AC input. Okay, it varies from time to time. Okay, 0 to 180 to negative 180 and so on and so forth. Okay, so like it records everything. Okay, so systems with continuously variable signal, of course. So like for example, an analog clock. Okay, so there's a lot of variation or there's a lot of noise that is coming from an analog because it works via mechanical. Okay, like for example, our wall clock, that is an analog. Okay, so there's a lot of factor. What if there is heavy wind? Okay, so it might affect the swing of the clock. Okay, so that is one factor, or that is one noise that you could say that it will affect our analog clock. Okay, so have a continuous varying signal. So yeah, it transfers from one medium to the next, like mechanical inputs. Building. Hala ko may nabura ako. Kinig ko pala ako, Control C. Anyway, so yeah, that's it for the analog and electronics. And we have here microelectronics. So from the word micro, okay, so it deals with small electronics, okay, design and components. So in here, it is now under or in here we have components which is under microelectronics, which is the transistors, capacitors, inductors, resistors, and diodes. Okay, or even insulators and conductors. So those are actually the basic components that you'll be using to make a single device or a single system. Okay, so all of them is under this so-called microelectronics. Okay, and then here are the other branches of electronics. So we have IC, integrated circuits. So you guys already know this one composed of many circuits or many components, okay, to form a single circuit, which is called the IC or integrated circuits. And then we have power electronics. We have optoelectronics, which deals with light, telecommunications, which deals with signals maybe or communications. And we have semiconductor devices, embedded systems, and then audio electronics. Okay, so these are just the other parts which I will not explain anymore, since we will not be discussing the fundamentals or the basic of what is power, opto, and then telecommunications. So maybe integrated circuits. So this is the only one that we will discuss a little bit more. Okay, so before that, let me just tell you guys that we have two types of signals. We have the AC and then the DC. So since you guys are already third year, am I right? Third year or still second year? Hello guys. Ano na kayo? Second year or third year?
Third, sir.
Regular, sir.
Yung iba, sir.
Third tapos merong second, no? Okay, so yung most of you are already done with electronics. Okay, subject electronics. So be sure, ha? Because sure kung second year or third year na. Okay. Anyway, so you guys want to know what is an AC. So this one flows alternately. And we have DC, which only flows in one direction. Okay, so it could be negative or positive only. But mostly when it's DC, it's positive. Okay. And of course, when you say AC, so it's recall. So it has an amplitude, of course. So it could be 60 hertz, 100 hertz, 20 hertz, etc., etc. And then let's say you have a voltage. Where's that one? I know there's no given voltage. But when I say 6 hertz, this one is reversing 120 times per second. Okay. So 60 for the positive and then another 60 for the negative. But for the direct current, so nothing. Okay, it's just the voltage that is given. So it will start with 0, of course, and then the voltage given. So it's constant. Okay. And then voltage and current. So you guys already know this one. Voltage is rated in volts, and then current is rated in amps. So this is just an example. So 9 volts and a current of around 500 milliamps or milliamps. Okay. And then we have here the types of circuit. So I'm pretty sure that you guys already know this one. So as always, when we see electronic devices, so it's always a closed circuit. You could not say that it's an electronic device if there is no loop of current. Okay. Yeah, you could still say that that one is an electronic device, but that one will not work. Okay. It's just a bunch of components. Okay. Unless there is a flow of current or it is a closed circuit and then current will be able to flow on that circuit or on that electronic device, then that's the time that we can say that it's an electronic device. Okay? And if it's an open circuit, then this is just two components. So we have here the probe or the wire, and then we have here the LED. Okay, this one is not an electronic device. Okay? So we must have a closed loop for us to be able to say that it's an electronic device. Anyway, so they are just the types of circuit. And we have here the series versus parallel. So you guys want to know this one. For series, there's only one path or one flow of current. Okay, so component, next is component, another component, etc., etc. And then we have here the parallel. So this one is wired side by side. So I hope that you guys want to know what is a parallel look like. Okay, so it has a node, okay, and then branches inside of it. Okay, and it has many paths, or your currents will split into many paths. Okay, and we have here the common basic electronic components, in which you guys maybe already know most of this. So we have resistors. Pretty sure that you guys already know this one, and we have capacitors. So alam niyo na rin to. LEDs, transistors, inductors, potentiometers, and then integrated circuits. Okay, so we could say that the one that we're trying to, our goal, okay, in this module is to create similar like working integrated circuits. Okay, so integrated circuit is composed of many components inside. So it has resistors, transistors, capacitors, etc., etc., which is programmed to do something. But in our case, since we are starter or beginners, so we will start with individual resistors, individual capacitors, LEDs, and transistors, and inductors and potentiometers. And if you want to use a certain IC or integrated circuit, so no problem, as long as you know how to use that one or what is the specific model of that IC. All right, so any questions so far up to this point?
None, sir.
None, sir.
Okay. So since you don't have, okay. So if you guys do not have a question anymore, so you guys may go for now since we don't have enough time anymore. So I guess we only have 20 seconds left. So just see you guys on the part 2. Okay. So wait nyo lang kaagad. After neto, popost ko na yung new link. Then join na kayo kaagad. So again, you guys can eat while listening and watching. Okay. So goodbye for now and see you guys later.
Bye,
Yes, sir.
sir.
Bye.
Bye, sir.
Sir.
Bye. All right. So again, any question, guys, or clarifications up to this point? Okay, so we'll just wait 1 more minute. Maybe the others are not here yet. Forgot to include here diodes. All right. So are you guys there already?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Sir.
All right. So I like that. You guys are responsive and cooperative. So thank you so much. Again, I appreciate that one. Okay. I appreciate you ng bawat instructor, lalo na hindi namin kayo nakikita. Okay, so let us now continue. So resistors, you guys already know, already know this one. This one is a basic component of when it comes to electronics. So it opposes or limit the flow of a current. Okay, simple as that. That is the role of our resistors, and this is how they look like. Well, I'm pretty sure that you guys already seen a resistor in physically or in reality. So this is how they look like. So they have a lot of different colors, or we could say bands. Okay, and each one of them represents a meaning. Okay, so this one represents the value of that resistor. So here's the usage. So let us say that you have a 9-volt battery and you want to turn on an LED light, turn on a light emitting diode, okay, or LED. So here's the connection. We have the battery right here, which is 9 volts. So you have to put here, let's say, a 350 ohm resistors before passing through the LED. Okay, why? Because 9 volts is so much for a 2 volts red LED. Okay, so what will happen if you don't have this resistor? So this will basically, there's so much current, and then this will absorb so much light, or will create so much light, and then maybe after 5 minutes or 10 minutes, this will fail, or this will get destroyed, or this will not work as an LED anymore. Okay, so that is why we have a resistor here to limit the current that will flow from our voltage source, or 9 volt. Well, it's okay if we have 2 volts right here. But in some cases, 2 volts, exactly 2 volts is not advisable. Okay, since we have a resistor that is will limit the flow of current. Okay, just by passing this wire, it will already lessen the current that will pass through this LED. So maybe 2.1 or 2.2. Okay, so you can adjust it one that right way, so you can have uh, a better lit or a better light or outcomes of your LED. And in that case, it will not create so much heat. Okay, and here are okay, started this one. This is how to read a resistor. So we have 4 bands: first, second, third, and then the multiplier, and then the tolerance. Sorry, we only have 1 and 2, and then multiplier, and then the tolerance. If we have 5 bands, okay, or 5 color of a resistor, so it will reach up to third digit. So we even have up to 6 bands. So you can have first, second, third, and then fourth digit right here, and then the multiplier, and then the tolerance. But mostly, okay, a resistor only consists of 4 single bands, okay, or 4 color bands. So you're going to use, or you're going to read that by first digit and then second digit only, and then the multiplier next week, and then the last one is tolerance, right? So if you want to learn on how to measure a resistor, so you can always visit YouTube. Okay, so there's a 2-minute tutorial on how to read a certain resistor. Okay, and then we have here diodes. So probably you guys know what is a diode. So this one allows an electronic current to flow through them in only one direction. So for example, our current will only pass through, or will only be able to pass through from anode to cathode. So if we have an AC, okay, so once it reached the negative part, then it won't be able to pass through this anode. Okay, so it will only be able to pass through if it's going from cathode to anode. So as you guys can see, this one will only allow one flow of current, or if it's positive, positive only. Okay, if it's negative, negative only. Okay, so that's how our diodes work. Okay, so they are also known as rectifiers. Okay, diodes can be used to change alternating currents and once flowing back and forth around a circuit and constantly swapping direction into direct currents once that allows always flow in the same direction. Okay, so in your electronics, they have discussed one. Okay, so just go back to the notes that you have on your electronics if you forget how diodes work. Okay, and then we have here capacitor, okay, which is also very useful when it comes to in every single devices that we have right now, okay, or in our appliances that we have right now. So this is one very good uh, component, okay, that will save you to cost more if you want to repair or if there is a damage that you got to your appliances. So this one is like a battery with very low capacity. Okay, since it has a low capacity, uh, like look like a battery, okay, or like working battery. So it charge very fast and it discharge very fast. Okay, unlike a battery, a real battery, it charge very slow and it also discharge very slow. Okay, but for a capacitor, so this will charge very fast and then this will discharge very fast also. Okay, so the main usage of a capacitor is actually to have a time delay. Okay, like for example, you have already removed the socket of your let's say TV. Okay, so after 2 seconds, that is the only time that it will totally lose all of its power. Okay, so the reason for that one is to avoid a sudden fluctuation of going in and going out of current. Okay, so in that case, we uh, will be able to avoid to have a damage. Okay, to damage your components of your TV or any appliances. Okay, so this one is also used to remove noise. Okay, like for example, we have AC input, right? So this one can smoothen out that AC into DC, thus removing a noise. Okay, so you can say that the smoother the flow of current, the lesser the noise. The higher the a chance to fluctuate, the higher the noise. Okay, so this is where a capacitor comes to play. Okay, or making the supply voltage of a circuit more stable, or in other words, just to make the supply or the current super stable. So that is why they call this one rectifier, because if we have this AC, we can have a smoother voltage output. Okay. So one usage of this one is a blinking light. So as you guys may all know, in the blinking light, it or electricity comes or goes in, and then after that will goes out right away. Then goes in and then will goes out right away. So there's a big chance that in the blinking light, it will be destroyed, okay, right away, or it will fail working right away. Okay, so that is why we have capacitor to smoothen out or to slow down the going in of the current and then going out of the current. Okay, and then we have here two types of capacitor. So we have the polarized and then the non-polarized or non-polar capacitor. So when we say polarized, so from the word itself, it has a polarity that you have to follow. So it has a implicit polarity, so it can only be connected one way. So you must know the polarity of a polarized capacitor. So the other one is of course non-polarized, which doesn't have a polarity, so no implicit polarity. It can be connected either way. Okay, so vice like a resistor. Okay, so the only advantage of having a polarized capacitor, this one costs much less. Okay, unlike the non-polarized, this one is a little bit more expensive. So you can see that either of those two you won't go wrong. So they work the same functionalities, or yeah, there's no advantage and disadvantage. It's just the cost of of buying that component or type of capacitor. Okay, and then we have another name for this non-polarized. So sometimes they also call this one bipolar capacitors. Okay, so yeah, could be this way or that way. That's why it's called bipolar. All right. So any questions so far up to this point? The capacitor and diodes.
None, sir.
Answer.
All right.
Answer.
Okay, so let us now move on to the next one, which is the LED or light emitting diode. So to those who still didn't know that this one is actually a diode, so this one is a diode, okay, which only allows a single single flow of current. So as you guys can see, this one is polarized also, wherein you have to follow the polarity. So the longer one is the positive one, and then the shorter one is the negative one. So if you're going to put it the other way around, so it will not work. Okay, it will just simply block the current or the electricity that's flowing on that LED. So yeah, this, as you guys may all know, LED is just an indicator or for a visual feedback. We don't really use LED to use as a light, or to light up something like a flashlight. Okay, it doesn't work like that. So the main role of LEDs in our world is to use that one as visual feedback. If to check something, if there is really a current that is flowing at that point, and or just an indicator, okay, if it's turn on or turn off. Okay, or you could have a cool light show circuits. Okay, so you could also do that one. So here are the colors of LED. We actually have two types of LEDs. We have the single color and then the multicolor. So single color for now. See, as you guys can see, the most common color that you will see on the electronics shops is the color red. Okay, some cases we may also see green or yellow, but in some cases blue or yellow or soft white is quite rare, especially the purple one. Okay, mostly we are using red or a green one, or RGB, red, green, and then blue or yellow. Okay, so yeah, those are the types of color that we can buy on the electronic shop. And yeah, and then here's the another LED, which is the multicolor RGB or multicolor LED. So from the word itself, multicolor, it can provide many colors. Okay? So it has actually an individual color, which is the red one, the green one, and then the blue one. So you can actually combine two colors, like for example, red and green, so just lit up the red one, I mean the red connection, and then the green connection, and then no current that is flowing on the blue connection. And then the other one is of course the ground. Okay, so if you want to have a single color only, then just have a flow of current on that single connection. Like for example, red, then red only. If it's green, then green only. If it's blue, then blue only. All right, but you can have simultaneous colors like red plus green, red plus blue, or even red plus green plus blue. So it depends on the circuit. Okay. And then we have here the power types of LEDs. So this is not the one that we're talking about. Wherein low power LEDs is just for indicator, or the one that we're calling standard LEDs, the small one. And then we have high power, wherein of course the more power, the more light that it will provide. So this one is the one that we are using for our in our houses to light up something or to a certain place. So this one's like a bulb or a lamp or a light intense applications. Okay, but for the other one, it's just an indicator or indicating something. So not for actually illuminating a space or a certain area. Okay, so low power for the small LED and then high power for the bigger LED. Right. So let us now move on to the transistor. So transistor is another basic component which has three connection. We have the base, collector, and then emitter. But we will not discuss those one by one. I have prepared just in case you guys are confused on how transistor work. So I have prepared a video. Okay, so it's under module overview. And then right here, so transistors, how do they work? So this is a, I guess, 7-minute video, 6-minute video only. Okay. So in here, you will be able to fully understand how transistors really work. Okay. But for now, I'll just give you a short definition on what a transistor is. So it is actually under a semiconductor device, okay, or semiconductor electronics. So it is used to amplify and switch or work as a switch on our electronics. Okay, but the main functionality of transistor is to amplify your voltage. Okay, from maybe let's say from a microphone, it will be able to amplify that to our speaker. So that's creating a stronger or louder sound rather. Okay, and in some cases, we also use this one as switch. Okay, so you have to meet a certain call this one certain amount of electricity or certain amount of voltage for you to be able to turn on a transistor. So if it wasn't able to reach that certain electricity or voltage, then it won't be able to turn on. So that is why sometimes we use this one as a switch. Okay, so a bit of current on the base produces a current of maybe 100 times more depending on the transistor through the collector and emitter. So as you guys can see from, let's say 1 volt or 1 current or 1 ampere, it can provide 100 times more. Okay, so that is why it can amplify a certain current. Okay, so it can be used to build amplifiers. Well, mostly they use transistors to build amplifier, okay, because of its usage wherein it can amplify a current or a voltage. So we have two types of transistor. We have the NPN, okay, negative, positive, negative, and then we have the PNP transistor, which is a positive, negative, positive. Okay, so in here, in NPN, so it allows electricity to pass from the collector pin to the emitter pin. So if you still don't know how transistor works, again, you can visit that one, and then they will explain where is the collector one, where is the base one, where is the emitter one. Okay, and then for the PNP resistor, so the electricity is coming from the emitter, and then will go to the collector pin. So it's the opposite of this NPN resistor. All right, but both of them serves to the same functionality wherein they can amplify and they work as a switch also. Okay? Just a different flow of current. And then of course they have their own advantages and disadvantages. Right, so much with that. So let's now move on to the inductor. So you could say that this one is similar with capacitor. So both of them stores energy. Okay, so both of them protects our components from getting damaged from sudden fluctuation of the current, okay, or sudden loss of the current. Okay, so since this one stores energy, then this one is like also charging, but it doesn't actually store the energy from inside of it. Okay, it's just that it has a special thing which is called the magnetic field, wherein for a very short time it can store a magnetic field on this coil or in this loop wire. Okay, so that is where they are being stored. So it's not actually being stored, but they are, they keep on flowing onto this wire or electric coil. Okay. So it also stabilizes the flow of current from sudden fluctuation of the current. So it's like a capacitor. So if you have a capacitor plus an inductor, the better. Okay. The more control that you will have, or the more safer of electronic that you will have. Okay. So the usage of this one can be used in motors by creating mechanical energy from its electrical and magnetic energy. Okay. And of course, there's a lot more when it comes to usage of inductor, but these are just some. And then the next one is the potentiometer. So as you guys may all know, this one is actually a voltage divider. Okay, as you connected this one to your circuit, it is now dividing the current that is flowing to your electronic components. But of course, if it can divide the current that is flowing, it can also minimize or control, or it can also allow the current that will pass through on that current. So you can say that this one is our mini controller, okay, to control the amount of current that is passing through to your current, passing through to your circuit. Okay. So commonly used to control electrical devices such as volume controls on audio equipment. So you can say that rectifiers plus potentiometer, not rectifier, inductors or capacitors or transistors plus potentiometer will give you so much control. Okay, like it is already safe when it comes to sudden fluctuation, but you can still control it, but you can even control it. Not still, you can even control it with the use of potentiometer. So the safer the control, okay, of your current that is flowing through your circuit. Okay. And we have here the integrated circuit, which is the last one. Okay, so this one is actually consists of many basic electronic components. So we have a lot of types of ICs. So you can search on the internet what are their usage, but they look the same. All of them mostly look like this. Okay, so we have a lot of pins on the right side and we have a lot of pins on the left side. So trying to fit inside. So it could be an amplifier, could be a microprocessor, it could be a USB serial converter, or it could be anything. Okay, that's because we have multiple components inside wherein they are programmed to do such thing. So that is why it could be anything. That depends on the creator or who is the one who put the components inside of it, and then how they program it. Okay. So yeah, this is the last basic components that we'll discuss. And then we have a lot of other more components, okay, that you can search on the internet, but these are the basics. Okay, so if you want to learn more about basic components, then you can search more on the internet. Okay, especially if you are going to create a complicated project. Okay, so you can search more. And then here are some common integrated circuits. So we have the single circuit logic gates. Okay, so this is an IC. Oops, half others. This is another IC, full others. This is another ID, multiplexers, the multiplexers, encoders, and then decoders. So all of those are individual ICs wherein they serve different roles in our circuits. So all of them, or some of them, performs a logical operation like AND. Okay, and then NOT. We even have NAND, or NOR, and then exclusive OR on those circuits. Okay, so it's a combination of logical operations for them to work as half adder, full adder, and then multiplexers. And then here are some common integrated circuits. Okay, so we have, of course, the op amps, which is very common, and then we have the 555 timers, which is also common, voltage regulators, motor controllers, microcontrollers, microprocessors, and then many more. Okay, so yeah, that's it for the basic introduction to electronics. So any questions so far, guys?
None, sir.
None, sir.
None, sir.
Wala naman, sir.
Answer.
Okay, so to be honest, this one is maybe 20% only when it comes to introduction to electronics. So I would like you guys to check out more other basic components and then how they work. Okay, so yung concern lang natin dito, our only concern here is the components. So these are the things that you need to really read how they work, because that is your lab number 5. Okay, so I would like you guys to propose a simple project, okay, with the use of basic electronic components. So if you want to, include another components that you already know how it works, then no problem. Just let me know that you're going to use this component, and etc. etc. Okay, and then of course you have to define why you chose or decided to propose that project. So what is its importance in our society? Okay, so not just a project, it must have a significance in our society or in our daily lives. Okay, so not just a nonsense project. Okay, should be an important or a useful, okay, not really important, should be a useful project. Okay, so you can use FreeSync to create your sample layout. Again, you can search for other basic components that you can look onto our FreeSync. Of course, I'm pretty sure that you can find that components if ever you have found new components that we wasn't able to discuss on this module. All right, so for now, I would like you guys to propose a simple project, okay? Not a complicated project, but just a simple project, okay? And then what its usage and what is the importance of it in our society or or around us, okay? Chose lang. Right, so yeah, that's it for the module 3. So are we clear so far regarding with your lab number 5?
Yes, sir.
Or can I use actual
Yeah,
circuit?
you can use an actual circuit, especially if you have the breadboard, the connecting wires, have the battery, the resistors, etc.
Okay, sir.
Okay, so you can test that one out first, maybe in actual, and then before creating that one on the FreeSync. Okay, so any other questions or concerns? Okay, so according from Mr. Jason Romer Caveria, so he have already used fritzing before. Okay, so fritzing is a doesn't seem to be user friendly. Really, for me, it seems to be friendly than the other applications that you can create, or you can experiment using a breadboard. Anyway, I hope that this tutorial will be able to help you know on how to create a simple project. Okay, so when it comes to routing the wire that you will see on the actual project on how to put them on the actual PCB, so that is not a requirement for now. Okay, so that will be on finals. Used to it because in my previous subject as to use Proteus. So yeah, that is another application. So you guys can use another application if you guys want. Okay. So what important is I would be able to see the virtual schematic diagram of your project. Okay. So you can use Proteus, you can use any other applications you can find on the internet. All right. So anyway, so this is the last one already. So now that you have learned the basics and fundamentals of electronics, so we could say that all the components that we have discussed has a very important role in every circuit. So the question here is, now you will be given a chance to choose only 3 components from what we have discussed module. So what are those 3 components and why? Like why capacitor, why resistor, why inductor? Okay, why not a diode, and so on and so forth. So what do you guys think is the importance of this one rather than choosing this component? Okay. So yeah, just a simple scenario and simple question. So any questions or concerns
None, sir.
None, sir.
that I have
Wala
missed?
po, sir.
None at the moment.
None for now. Okay. So I highly suggest or advise you guys to watch the video materials. So yeah, there are other links in the YouTube that you can find, but I guess these are the most helpful one. Okay, so I've watched most of them. Okay, and then I've chose the most uh, easy to understand, and then the most maybe most good definition or easy to understand definition. So yeah, pang ano to, pang beginner kumbaga. So the others are quite techy already or very technical, but for these 6 links, they are super friendly for beginners. So you'll be able to understand this one right away. Okay, and then you can also download those 3 PDFs if you want. Okay, so they are very helpful when it comes to understanding the basic electronics or the introduction to electronics. Okay, so let me just show this one to you guys. So we have here the PDF, which is the basic electronics, where it will talk about semiconductors, the type of silicons, what is a diode, how does it work, and how it doesn't work, some applications of diodes, and then how a transistor works, etc. etc. Okay, so they are very useful. Yeah. And then the another one here is more on concepts of electronics. So you actually have a lot. Yeah. So it will give you on how to compute, etc. And then it will give you a schematic diagram on what will be the voltage input, voltage output, the gain, the current, etc. Decibels, wattage, inductance, capacitance, and so on and so forth. All right. So yeah, I guess that's it for today's meeting. So if you guys do not have a question anymore, then you guys may now go and then have a happy lunch. So thank you guys for coming. So I really appreciate it. So see you guys next meeting, or probably not. I'm not really sure. So because for today, will only be the